Okay, today we're doing topic 3.4, differentiating inverse trig functions. And before we begin, this is basically some of more things that you have to memorize and you would write in your calculus Bible to have these derivatives essentially. Okay, so we can use implicit differentiation to solve the derivative of the inverse sine. Remember, the inverse sine is used to find the angle. It undoes sine. So that means if y is equal to the inverse sine of x, remember inverse functions, you switch the x and the y. So then I can rewrite it as sine of y equals x. So then the derivative d dx of sine y equals d dx of x, just taking the derivative with respect to both sides. So the derivative of sine is cos, leave the y the same, and then have the extra dy dx on there. And then, of course, the derivative of x is 1. Then if I cross multiply, I get dy dx is equal to 1 over cos y. Okay, so recall that sine squared y plus cos squared y equals 1 from 40 pre-cal. If we solve for cos y, we get cos squared y equals 1 minus sine squared y by just moving the sign over. And then cos y would be the square root of 1 minus sine squared y. So then if I want to substitute that in, do you see that we have 1 over cos y before we found that the dy dx is equal to 1 over cos y. So if I want to rewrite that, this would be dy dx is equal to 1 over, now instead of writing cos y, I'm going to write the square root of 1 minus sine squared y. And then that would be replaced with what I have as from before, which is 1 over the square root of 1 minus x squared. And that's taken from the identity that sine y is equal to x. So I'm just replacing that in there. So now I've proved what the derivative of inverse sine is. Okay, so basically after that, you just have to memorize all of these. Arcsine and arctan, arcsecant, all those are the same thing as inverse. So sometimes you'll see the vocabulary of arcsine. That's the same thing as inverse sine. So again, you're going to have to memorize all of these things. If you want, you can use that this is 1, this is x, and this is the square root of 1 minus x squared, and this is the angle y. And then sometimes people, memorize that. For instance, if you look at this triangle, it's a right triangle, of course, and you want the opposite over the hypotenuse, or the adjacent over hypotenuse, you can make some of the ones that you have memorized. But in the end, just memorize it. Okay, so let's try some questions here. Okay, so this is the derivative of inverse sine of 2x. Okay, so essentially, this is a chain rule because this is inside the function. So we could write this as y equals inverse sine of 2x. Okay, and that's the u in our formula. So if I go back to the formula for inverse sine with a chain rule, it says that you should have u prime over 1, the square root of 1 minus u squared. So that would just mean that y prime would be the square root of 1 minus 4x squared, because I'm squaring 2x. So that's 2x times 2x is 4x squared. And so the derivative of 2x is 2. So then this would be my final answer. Okay, so arctan. Do you see this is our u? So if I go back to arctan, do you see it's u prime over 1 plus u squared? So the derivative then would be 1 plus, well, the 3x would be squared, so 9x squared, and then the 3 would be the derivative of 3x. Okay, so of course, this now gets a little bit more complicated when we have the chain rule with it written with a square root. So I'm going to write this as the inverse tan of x to the power half. So then you can see the chain rule a little bit better. Okay, so if I go back to the memorized value, it's u prime over 1 plus u squared. So y prime would be 1 plus u squared would be 1 plus the square root of x squared would be x. And then the derivative of x to the power of half would be 1 half x to the power negative a half. And of course, we can't leave that like that. So y prime would be, you'd have 1 on top. And then the 2 root x would be on the bottom. And then the 1 plus x. Okay. So the next one is the derivative of secant of e to the power 2x squared. So this is like a chain and a chain. It's crazy. Okay, so if I look at the memorized value for inverse secant, it would be u prime over the absolute value of u, which means it's just positive, and then the square root of u squared minus 1. Okay, so the first thing we have to do is the power rule. So the power rule would give you 2 inverse secant of e to the power 2x to the power 1 if you want to put the 1. Okay, just to see that I did the power rule. Then you have to do the derivative of inverse secant. So remember that was, if I go back here, that was u prime over the absolute value of square root yada yada. Okay, so it would be the absolute value of e to the power 2x, and then it's going to be the square root of u squared. So if I square e to the power 2x, I get e to the power 4x minus 1. And then the derivative of e to the power 2x would be 2e to the power 2x. Okay, and then knowing that, like, what does this absolute value mean? E to the power 2x is a graph that goes like this. So it's positive no matter what. So that means I can actually cancel this e to the power 2x with e to the power 2x. Okay, so simplifying, I get this 2 times 2 gives me 4 inverse secant of e to the power 2x over the square root of e to the power 4x minus 1. Okay, so last 2 examples, we have a product rule. So f prime g plus fg prime. So y equals, the derivative of x is 1, leave inverse tan alone, plus leave x alone, times the derivative inverse tan is 1 over 1 plus x squared. So let's simplify this. So y prime would be inverse tan plus x over 1 plus x squared. All right, last example, we have a chain rule, of course. So again, going back to what's the memorized value for sine, inverse sine, it is u prime over the square root of 1 minus u squared. Okay. So y prime would be, okay, remember this is a chain rule, so that's going to be our u. So that's going to go on the bottom as 1 minus tan squared of 3x. And then goes on top would be my u, which the derivative of tan is secant squared 3x. And then there's another chain where we have to do the 3, so then the 3 just goes beside it. And then that's my answer. All right, so practice makes perfect. And if you can come up some ways to